Okay, cool. We have a working ERC20 contract, even with some tests now. Let's now try to deploy this. We already deployed this when running our tests, but only to a local blockchain running only on our computer. So now let's deploy this to a real Ethereum network. There are a couple considerations when doing so. So as a reminder, what we need to deploy contracts, you'll need the contract's bytecode. This is created by running npx hardhat compile. A private key to an Ethereum address with enough ether to pay for gas. So for testnets, if you remember, this can be gotten from faucets. And a deployment tool or script. The first time we used Remix, so this time we will use hardhat. And an Ethereum node service, like Infura. For Remix, we used MetaMask, which actually was using Infura under the hood. If we now want to deploy with hardhat, we will need to add this integration ourselves. So inside our hardhat project, you'll see there's already a scripts deploy file. So we can just use that. And you'll see this already has the code to deploy the example contract greeter. So we can just change this now to our ERC20. And don't change anything else. Just name the contract ERC20. And then it says, oh yes, of course there's an error because our ERC20 is expecting 2 values. So the first is the name and then the symbol. And this is also ERC20. So this is really all we need to do to change the script. And you may actually deploy multiple contracts here or have more complicated logic depending on what you need. But for us, this is really enough now. And now we only have to add actually the integration for the node service. So let's just use Infura and go to your hardhat.config file. And then you'll see there's a config here that has networks configuration. So here you'll see Robson as a testnet, and you'll see there's a URL and a private key. And both of those values come from process.env. And what it's actually doing here is using .env, which is a package that is just loading up a configuration file. So you'll have a .env.example already in your project. And here you can define these variables. And the idea behind the .env is that you have things that are sensitive, like a private key. And you, of course, don't want to submit this private key to something like GitHub. Actually, when people do that, they usually lose all their money because there are actually bots out there just looking at public GitHub repositories for people accidentally submitting private keys. And if they do so, then they just transfer the money as soon as possible. So yeah, just be very careful when you're handling with private keys. This is obviously like not a real private key here. And then I'm not going to show you because it's my private key, but I have a .env file now here. So just copy, paste the .env.example and fill out the information that you need here. So what my .env file looks like is actually, I have the Robson URL and Rinkeby URL. And I'm using Infura here. So this is when you go to infura.io, you create an account and then you can get this URL and the key to actually talk to the service. And obviously Infura is, you can also pay for it to have a higher uptime and more features. So that's why you also should keep this Infura key here private. And of course the private key itself. Okay, so now we can actually add this. And we don't have the Rinkeby network yet. So let's just use a copy and paste the Robson configuration and change it to Rinkeby. And then I defined Rinkeby URL here. And you would do obviously the same if you even wanted to deploy to mainnet. You would change that here. Although there are some special considerations for mainnet that we'll talk about at the end. Okay, so now to deploy the contract, all we need to do is run npx hardhat run and then the scripts deploy.js and pass the network that where we actually want to deploy to as a parameter with -- network and say Winkeby here. And now assuming you actually have enough Ether funds to pay for the gas on the private key that you provided, this would now work and deploy it to the actual Winkeby testnet. So this will take a few moments, and when it's ready, it will show you the address. And this address then is actually an address that exists for other people to be used. So you could take the address and actually use it on winkeby.etherscan, for example, and you would find, so here this 43E8, you could actually look it up on Winkeby Etherscan, and you would find there is actually this contract, and other people, of course, can interact with this contract here as well. So this was the way to deploy it with Hardhat. If you actually just wanted to deploy it with Remix like we did in the first time, that's also possible. In our case, it was just the erc20.sol. You could just copy paste that into Remix and use it. Once you have more complicated projects where you have multiple files and not just all in one single file, you can't just copy paste because you have multiple files where all the code is. For that, Hardhat actually has a nice little feature, which is npx hardhat flatten. And then you just pass the contract that you want to flatten. So in our case, let's say erc20.sol. And this would now use the contract and basically print it out all in one single file. Obviously, like I said, in our case, it doesn't really make sense because it was all in one file anyways. But this is pretty useful if you have more complicated projects and you wanted to deploy with Remix, and then you can use this command, and then you would usually pass it like this to a new file, and then you have a flattened erc20.sol that you can just copy paste into Remix and deploy it the way we did it the first time. Okay, so this now was for a testnet with no real value. But when you deploy to mainnet, there are special considerations. Of course, the first one, and very importantly, is gas. On mainnet, you'll pay real money to pay for the gas. So you want to be aware of that. And if you were to use Hardhat, the gas price will be calculated dynamically. You can manually set this in the script, but this becomes messy when deploying multiple contracts. In general, I would recommend using Remix for deploying to mainnet, as it will give you more control over gas prices, and it can become quite expensive to deploy contracts on Ethereum otherwise. Then secondly, if you want real users with real money, you may want to consider getting your contract audited. We all know about hacks, and an audit can help to prevent that. But of course they are pretty expensive to get. Lastly, after the deployment to mainnet, you should verify the contract source code on Etherscan and Sourcify. Of course, you can even do this for testnets, but for mainnet, I definitely recommend doing both.